Okay, hello guys. So welcome back again to my third class, which is we're going to talk about forces in motion 2, another part. So today we are still in the same topic, which is resultant forces, resultant force. So in this topic, I need you to really pay attention because you really need to understand, okay, deeply in how the resultant force when it is in a normal plane and also a slant plane. So that is what you have to understand today. Okay, now let's just dive into it. So today I'm still going to discuss about resultant force. Now, what is resultant force on an object in various states of motion? Now, first thing is you learn about how to find the resultant force by using the two methods and calculation methods. Okay, so you had triangle methods and also parallelogram of forces methods, right? So that was in the last class. So today we are going to use a free body diagram of an object to understand about the resultant force. Now, still, first thing is you still have to remember what is resultant force. I believe a lot of you can answer this. Now, I'm going to say this again. Please remember, what do you understand about resultant force? Please remember the definition of resultant force. Because if you don't understand what is resultant force, then it is impossible for you to understand the whole idea about this free body diagram of an object. Okay, now let's say, what is a free body diagram of an object? A free body diagram of an object is a diagram that shows all the forces acting on that object only. I repeat again, a free body diagram of an object is a diagram that shows all the forces acting on the object only. Now, I give you two diagrams here. So the first one is a book on a table. So you can see that the book and on a table, the diagram shows all the forces that experienced by that book. Okay, same, I have a luggage bag here. So this luggage bag is actually leaned to the wedge. Okay, and then you can see that all the forces are drawn on this diagram. So this is what we mean by a free body diagram. Now, next part. How are you going to draw it? I'm going to show you one by one. How are you going to draw it? Because it is very important for you to know how to label and how to draw the forces. If let's say you cannot draw and label the forces, when you want to answer the question, which is very abstract, if we give you sentences of question, then you will have problem in solving it. So that's why it is very important for you to be able to draw a free body diagram, okay, before answer the question. Now, this topic will involve problem solving, which will involve calculation. So I hope that you really bear with me, pay attention on how to do this. Okay, now I'm going to show the first one. Now, let's say I have a box on the table. So this box on the table is stationary. So how are you going to draw the forces? So the first thing is, you know, all the object on the earth is being affected by gravity, and all the object which consists of the quantity of matter will have mass. So that's why the first force that you must understand here is it has weight. Okay, and then we will have another reaction force. Okay, this we call reaction because normal reaction from the table, as long as this reaction, the normal reaction is the opposite force, opposite reactions to the plane. Okay, for example, this is the plane and then the object is on a table, so the reaction is opposite, okay, going outward. So this is the only two forces when the object is on a normal plane and it is in a stationary mode. Okay, now what if I have an object? Now this is the gray color is an object and this is a wedge. So I put it on here so that the wedge will not slip down. Okay, it will not go down the slant, right? So how are you going to label it? First thing is, it is still a stationary, means that the box is stationary, it is fixed on it. So how are you going to label the forces? So first one, what I have a reaction. Like I said, reaction is the normal reactions that according to the plan. So it is an inclined plan, so that's why the reaction is like that. Okay, next one, I have a weight. Now, how does the weight go on? Weight is always a perpendicular downwards. So this is how my weight go on. Okay, how my weight goes on. So you have to understand that it is always perpendicular towards the ground or floor. Okay, next one. This is my normal. Okay, what do I mean by normal? Is actually like this. Normal reaction from the wedge means that the wedge is actually holding the block from going down. So that's why I have a normal here. So this is what I have for this kind of situation. Now, remember that sometimes if let's say I do not have a wedge here, if I do not have a wedge here, then what I can understand is I have a frictional force which make the I have a greater frictional force that avoid the box from slipping down. Okay, it will not go down because the frictional force is great enough for it to stay on the box, stay on the inclined plane. So that's what you understand. You have to understand here. Okay, now we go one by one. I explain like this. I need you to do revision on it. So you have to practice yourself on how to draw out the free object diagram. If you don't do that, then you won't be able to answer questions. Okay, now what if when we consider the effect of the resultant force on an object, you only need to draw a free diagram of an object. What if now, let's say, what if the object that is given to you is moving? So they are moving, so they still have forces acting on them. So when you are drawing the forces, the forces on that diagram, you only need to draw the free body diagram of an object. Okay, you don't need to worry about the direction of the motion. The direction of the motion just show how does the thing move. For example, this trailer is moving if what I see here is to the right side. So and then after that, what I need to do is I just need to label what is the forces acting on it. Same, if let's say I'm using a rocket here. So the rocket is moving outwards. So what is the forces that I have here? What are the forces that I have here? So you have to understand that. Now I'm going to explain in detail how do I draw it. Okay, now let's say I have a trailer, a lorry. It's not a trailer, a lorry. So what does the lorry do? So the lorry is a moving object. Then the direction is moving to the right. What I see on the screen is to the right. So next. So first out of all, you have to consider the one that go up and down. Okay, normally when we talk about a free body diagram, we only talk about upward, downwards, left, and right. So that's the four direction. Okay, so this thing is moving. So again, I said up, down, left, and right. Okay, so that's what you have. So let's see here. So the first thing I will label here is the weight, because all the object, like I said, all the object in our world, as long as it is made up of quantity of matter, it has mass. So the mass is affected by the gravitational pull. So that's why we have weight. Then don't forget, we always have a normal reaction going outward because it is moving on a plane. Okay, plane road. It's a plane road, normal plane road. And then after that, we have to know that how does the car moving? How does the lorry move? So the lorry move, it needs a pulling force. So that's why I have a pulling force to the right side. Next one, I have an opposite. Okay, now because of the pulling force, of course, I have an opposite direction. So I have a frictional force. Now, I have one question here. Why do we need frictional force? Why do we need frictional force? Sometimes we will say that, teacher, frictional force will cause a lot of heat. It will cause friction, and then after that, it will produce heat, which that is the thing that we don't want. Now, here's my question. Why we need frictional force? Actually, frictional force brings benefits. So I need you to think about it. What is the benefits of frictional force? I'm going to ask you, I'm going to listen to your answer tomorrow. Okay, now let's move on. So this is what you have now, and then next one. Now this is a rocket. Now I cannot draw. I didn't draw the fire downwards, so means that the rocket is actually moving outwards. Okay, now so what is the thing that I have? First out of everything, still the same. Okay, this is a moving object. Okay, now always remember, as long as your object is on the earth, you will have weight, other weight. Okay, next one. So the thing is moving outwards, right? So when it is moving outwards, then you will have an engine thrust. We call it thrust of the rocket. So it will go up. Then next one. There's one more thing. When things go up, there is always a thing going backward. What? Newton's third law said that. Newton's third law said that. I'm going to ask you the question again tomorrow. What is Newton's third law? It is actually related to this. So because of the Newton's third law, that's why you have a air resistance. You have an air resistance there. So this is all the force. These are all the forces that you have on this rocket. So this is very important. If let's say you cannot draw out the free object diagram, then you will have problem in answering the question, especially to find out the resultant force. Now, how to find out the resultant force? To find out the resultant force, actually, we are using Newton's second law, which is F is equals to ma. So means that resultant force is the final product, right? Final product. So the final product of the force will be F is equal to ma. I repeat again, the final product of the force, the resultant force is always F is equal to ma. So you are going to use that formula in answering the questions. Okay, now, so up until here, I hope that you understand this one. So what if, now we have to go deeply. So after you understand about the free diagram, okay, free object diagram, you have to understand when the object is in a stationary state, what happened to the resultant force? I repeat again, if the object is in a stationary state, you have to understand what is the resultant force. Let's go one by one. We are going to go one by one, analyze it one by one. Let's see here. So when the object is at stationary, the velocity is 0. So when the velocity is 0, do you have acceleration? Of course, you don't have any acceleration. So your A is equals to 0. So according to the Newton's second law, which is F is equals to ma, then when you substitute 0 inside here, then you will get 0 Newton. So that's why the weight, the resultant force is equals to 0. And the weight of the car is equals to the normal reaction. We do not have a pulling force, a frictional force, because the car is not moving. So when the car is not moving, then you only have weight and normal reaction. That's all. Okay, so when the object is at stationary. Now, what if the object is moving with a uniform velocity? Now, in this diagram itself, it shows everything. You have weight, you have normal reaction, you have thrust, going forward, thrust, and also frictional force. It shows everything, but we have to go analyze it. We analyze it, what actually happened here. So when the object is moving in a uniform velocity, means that your velocity is constant and there's no changing of the velocity. For example, my car is moving at 80 kilometers per hour. So the whole journey I'm doing is only 80 kilometers per hour. I'm not changing my velocity. So that's the thing. Okay. When the velocity is not changing, there's no increasing or decreasing of the velocity, it means that your acceleration is equals to 0. Okay, so when your acceleration is equals to 0, according to the Newton's second law, F is equals to ma, your resultant force will also become 0. Why? Because you substitute 0 inside it. So now, here's the point. How are you going to relate between the resultant force and also the frictional force? So how are you going to relate that? So you are going to relate between R, W, F, R, and T. Remember, the symbol for frictional force I'm using here is F and capital R. So I'm using F and capital R. Okay, so here's the thing. So because the car is moving in a uniform velocity, so there's no resultant force. So when there's no resultant force, the weight of the car going up, the weight of the car, W, is equals to normal reaction R, and then the engine thrust T is equals to the frictional force. So that's the thing. Okay, understand one by one. So when object is moving in a uniform velocity, then this is what you have. So what if when your car or object is moving with an uniform acceleration? So now we can see here, when you are moving in a uniform acceleration, you can actually imagine how are you going to move in an accelerating mode. Means that if you are moving in an accelerating mode, you have overcome the frictional force. That's why you are accelerating. I repeat again, you have overcome the frictional force. That's why you are moving in an accelerating mode. Okay, now I go one by one. So when you are moving in a uniform acceleration, means that your velocity is increasing. So when your velocity is increasing, means that your acceleration is not equals to 0. So when your acceleration is not equals to 0, according to the Newton's second law, F is equal to ma, then your force will also not equals to 0. So here's the question. How are you going to relate their relationship between R and W and F, R, and T? Now, R and W will not be changing because they are not in a slanted motion. Okay, they are not in an inclined plane, so they are in a normal plane. So it's very easy. It's still R is equal to W, R, W is equal to R. So that's the same. But here's the thing. Because the car is accelerating forwards, that's why your engine thrust is greater than your frictional force. Like I said just now, when your car or your object is moving in a uniform acceleration, means that you are putting a greater efforts to overcome your frictional force. So that's why your engine thrust will be greater than frictional force. Where engine thrust is greater than frictional force, that's why you have T minus F frictional force. So that's why my resultant force will be T minus Fr. Here's the hint. If let's say after you analyze the diagram, you know that your T is greater than Fr, then your resultant force is always the bigger one minus the smaller one. I repeat again. After you analyze the diagram, you know that the T is greater than Fr. So how are you going to find your resultant force? Your resultant force will go to the bigger value minus the smaller value. Okay, so that's how it is. Now, when I go into the object in a lift, then you will understand that better. So now I'm going to talk about this, a very general situation first. Now, by using all this general information, you are going to try to solve the problem. Now, there are 3 examples here. I'm going into one by one. So if let's say you do not understand it, please rewatch it for a few times so that you understand how do you solve the problem, because it will not get further from the way how to do it, because almost every question are almost the same, but you have to grab what is the important information for you to solve the problem. Okay, so you have to go one by one. So first thing is, you see this example, you still have to sketch a free body diagram. So that's why it is very important for you know how to draw the free body diagram. So for example, figure shows a coconut of mass 2 kg falling with an acceleration of 9 meters per second per second. So sketch the free body diagram of the coconut. Next one, calculate the resultant force acting on the coconut. State the direction of the resultant force. What is the magnitude of the air resistance acting on the coconut? Now, there we go one by one. First, you have to draw. So when you sketch, let's say I have a coconut. I just draw like this. This is my coconut. And then the thing is falling down, right? So when it is falling down, I know there's weight there. So don't forget that I still have an air resistance. I do not have an R. I do not have a normal reaction because this is not an upland. It is falling down. So when it is falling down, that's why I have an air resistance there. Okay, so that's the thing. All right, now when the object falling down like this, actually we call this a free fall motion. Remember last year, if the object dropped like that, okay, it is actually it is falling in G. Okay, but we have to take into consideration the air resistance. Okay, we have to take into the consideration of air resistance, because last year when we talk about free fall motion, there's one condition that you have to take into consideration. I'm going to ask you tomorrow. Okay, what is the condition for a free fall motion to happen? Okay, now I'm going to ask you that tomorrow, but today I'm going to focus in this video. I'm going to only focus this one. What is the weight? Here's the weight, and then here's the air resistance. Here's the weight, and here's the air resistance. Now I move on. Calculate the resultant force acting on the coconut. Now I'm saying you have to look into the resultant force. Like I said, by using F is equal to ma, you are able to find the resultant force. How? Here I have mass is equal to 2 kg, and then my acceleration is 9 meters per second per second. So from the question, I'm going to use F is equal to ma, and then I know these are the information that I have. Then I substitute inside, I get 18 Newton. So that's how it is. Okay, so how to find resultant force is just F is equals to ma. That's all. Next one. State the direction of the resultant force. Where is the direction of the resultant force? Obviously, the coconut is dropping down. So that's why the resultant force is downwards. All right, the resultant force is downwards. That's easy. Okay, next one, last one. What is the magnitude of the air resistance acting on the coconut? Now I'm going to ask you. I'm going to find the air resistance. Okay, I'm sorry. I showed the old answer here. I'll go one by one. So this is your diagram. Okay, as the thing is moving down, object is falling down, right? So I know that my W is greater my R. Am I right? It's always like that, because when the thing is going down, then W is greater than R. If the thing is moving up, and then R will be greater than W. So that's the concept. Okay, so here, because the object is falling down, W is greater than R. So I know that to find my resultant force is equals to W minus R. So I have mg minus R, which is 18, 2 times 9.8. Okay, this one mg, 2 times 9.81. I'm using the acceleration gravity. This one mg, I substitute inside minus R. So now my question wants to find the air resistance. So I just move this 19.62. Okay, this R, negative R, I move to the left. I bring the 18 to the right. So that's why I have R is equal to 19.62 minus 18. Then my final answer will be 1.62 Newton. Means that the air resistance that experienced by the coconut is 1.62. But my weight, the coconut weight is 2 kg. 2 kg, if you multiply with 9.81, and then I have 19.62, which is 19.62 is greater than 1.62. That's why the object is falling down. I repeat this again. Maybe you cannot see. Okay, now you see, I find my weight is 19.62. The weight of the coconut is 19.62. And then my air resistance is 1.62, right? So this is very obvious. This number, this W is obviously greater than 1.62. That's why the object is moving down. So that's the thing. Okay, I'm going on. So example 2. Now, I have a passenger with a mass of 60 kg in a lift. Sketch the free body diagram using a symbol W to represent the weight of the passenger and symbol R for the normal reaction from the floor of the lift. Okay, next one. Calculate the magnitude of the normal reaction R when the lift is stationary, moving upwards with an acceleration of 1.2 meter per second, moving with a uniform velocity of 8 meter per second, given that the gravitational acceleration is G is equal to 9.81 meter per second. Now, this is the question. So when you see long question, do not get stressed with it. You have to analyze it. You have to leraikan. You have to go one by one and try to answer it. Don't scared with it. Okay, you have to practice your logic. You have to practice your computational thinking. Okay, that's very important. Now let's just go on. So first thing, sketch. So let's say this little girl is 60 degree. Okay, this little girl is 60 degree. 60 kg. Okay, so I'm going to sketch the free body diagram. So what do I need? I just need W for weight and R for normal reaction. So first thing is the weight. Okay, W going down, R going up. So that's the thing. Enough. Okay, you just, if let's say this is an exam question, if let's say you ask me, teacher, will the exam question be like this? Yes, it is possible because it is in your syllabus. It is possible. The exam question can be like that. All right. Now, next one. Here, I'm going to calculate the magnitude of the normal reaction R when the lift is stationary. So now, here's the situation. When R is stationary, when the lift is stationary, it means that your R is equals to W. Remember or not? When the object is at the normal plane. So that's why my R, okay, is equals to W. My resultant force, this one, FR, represent resultant force. Why? Because the lift is not moving. So when the lift is not moving, there is no resultant force. No resultant force going up, no resultant force going down. So F is equals to 0. Then my R will equals to W. So when R is equals to W, then I'll have this. Okay, R is equal to mg. So 60 multiplied with 9.81, I get 588.6 Newton. Easy, right? Okay, so easy, right? Okay, now, what if the lift is moving upwards with an acceleration of 1.2 meter per second? Now, here is the thing that you have to see. The thing is going up. So means that there is a resultant force there. The thing is going up. So there is a resultant force there. How to find resultant force? F is equals to ma. So your m is here, and then this is your acceleration. So that's how you get your resultant force, which means you have 60 multiplied with 1.2 meter per second. Okay, now, so because F resultant force is going upward, so that's why your R is actually greater than W. So when your R is greater than W, you always take the greater value minus the smaller value. So F is equals to R minus W. When I substitute MA here, MA is the one that I mentioned just now, 60 times 1.2. Put it here in front. It's equals to R minus W. My W is minus mg. So I just substitute inside. MA is equals to R minus mg. MA 60 times 1.2. R minus mg 60 times 9.81. So I get 72 is equals to R minus 588.6. Then I'll bring this one to the front. Then I get 72 plus 588.6. Then I get R is equals to 660.6 Newton. So when my when my normal reaction is greater than my weight, then the lift is moving upward. So that's the thing. Okay. And then next one. Calculate the magnitude of a normal reaction when the lift is moving with a uniform velocity at 8 meters per second. Now, this question is very tricky. what is the trick here? The leaf is moving at a uniform velocity, even though it gives you value 8 meter per second, but it still tells you that the leaf is moving in a uniform velocity. When it is in a uniform velocity, then your acceleration is equals to 0. So when your acceleration is equal to 0, then your resultant force will also become 0. So when your resultant force is 0, then W is equal to R. So when W is equals to R, then you still get the same answer as the first question, which is 588.6 Newton. So there are three conditions here. First one, when the leaf is is in a stationary mode. Second one, it is moving in a constant acceleration. The third one, it is moving in a uniform velocity. So try to digest and try to understand it so that you can know how to answer more questions after this. Okay, now last question, last example. Now, this figure shows the trolley of a mass with 1.2 kg being pulled on a table by a load through a pulley. The trolley moves with an acceleration of 4 meters per second against a friction of 6 Newton. Now, this question consists friction. It gives you friction already. Don't be stressed. I know the question is kind of long, and then I know it's kind of stressed. We will have to go and understand the free diagram. So I'm going to guide you here. Don't be stressed because basically, if you see this kind of diagram, it will not be different from others on how, it is almost the same. As long as it is about pulley system, then that is your free diagram. If that is about lift, then that is your free object diagram. If that is about an object falling down, then that is your free diagram. And then if, let's say, the object is on a slant plan, on an inclined plane, and then that is your free object diagram. So don't be stressed about that. It is almost the same. As long as you practice yourself for the basic, you will be able to answer all the other questions. Okay, now come back. The trolley moves with an acceleration of 4 meters per second. Okay, I mentioned about first, you have to sketch the free body diagram of the trolley and the load. Use W is equal to the weight of the trolley. R is equal to normal reaction of the trolley. FR is friction. T is the tension of the string, and B is the weight of the load. Now I have 1, 2, 3, 4, 5. I have 5 items here. You have to sketch in 5 items here. Then B, compare the weight of the trolley W and with the normal reaction. C, calculate the resultant force acting on the trolley. F, calculate the tension in the spring pulling the trolley. T, what is the mass of the load M given the gravitational acceleration G is equals to 9.81. Okay, now you have everything there. So now we are going to sketch it together. I know it's kind of tricky and then it's kind of hard, but don't sketch with it. We go one by one. So first thing is the trolley itself. The trolley itself has weight, right? So that's why you have a W there. It is on the table, so my R is going up. So easy. That's the first one. Done. Next one. You know that it has frictional force, right? So it will be going. Okay, I do this one first because this one, the weight of the load. I have weight of the load. It use B here. So they are not going to use W here so that you will not confuse. So that's why they use B here. Okay, they use B here. So you know that the load is pulling this down. So that's why I have B. Now always remember Newton's third law. There will always be an opposite directions of forces, right? So that's why I have a tension opposite here. Okay, then here another one. The tension will be like this. Okay, why? Because the frictional force is actually going backwards. So when the frictional force going backwards, that's why your tension is going forward. Okay, so that's the thing. So this is your free diagram, free body diagram. Okay, so please understand this. Next one, we are going to use this free body diagram to answer question. Now, you have to pecahkan dia kepada 2 dimension when you answer this question. I'm going to explain. Okay, first thing. Compare the weight of the trolley W and the normal reaction. Now let us just compare R and W. What do you think? What do you think? So this is on a plane, and then the object is only moving to the left and to the right. It's not going up and down. So that's why your R and W are the same. So when you see the word compare, if let's say you answer in this way, it is correct. Correct. Don't worry. That's why I said physics, you don't need have to write a very long statement. As long as mathematics statements, mathematics sentence represent what you want to answer, then it's correct. Okay. All right. Next one. Calculate the resultant force acting on the trolley F. Now, so I need to find F, right? I need to find resultant force. It's still easy. My resultant force, my mass is 1.2, and then my acceleration is 4. Just put it inside. Always remember, as long as you are asked to find resultant force is F is equal to MA, that's the final product. That's it. Then I'm going to find the tension of the spring in the trolley T. So now I'm going to find this tension. Here's the trick here. Here's the thing that you have to go one by one. So when the thing is being hung like this, okay, I know my resultant force just is 4.8, and then my frictional force is 6 Newton. So this is what I have. Okay, this is what is given in the question. Next one. Because now let's when I answer this question, I am only looking at this part. Okay, I'm only looking at this part. I'm not going to take into this consideration first, but you have to look at the question. You see, the question say a trolley of the mass 1.2 kg being pulled on a table by a log through a pulley. So the trolley moves with an accelerator against the friction. Means that this object is moving forward. Am I right? It's moving towards it to T. It is moving towards T. So means that your T is greater than FR. So when your T is greater than FR, that's why your formula will become T minus FR. So I rearrange it and then I'll get F minus FR because I bring this one here. Sorry, this one should be positive. I mistyped here. This is typing error. This one should be positive. I bring this FR towards to the front. So I have F plus FR. So 4.8 plus 6, I have 10.8 Newton. So that's how it is. I repeat this again. So when you look at this question, you have to understand how is the direction of the moving of the object first. So I know that this trolley is moving towards T. So that's why T is greater than FR. So to find my, to form my formula, it's always the greater value minus the smallest value. So that's why T minus FR. And then when I bring this FR to the other side, it should be positive. This one is wrong. This one should be positive, it's not negative. Okay, and then I have 4.8 plus 6 is equals to 10.8 Newton. All right, now last part. So now I want to find the mass of the load. Okay, don't be stressed with all these answers. Don't be stressed. I'm going to explain one by one. Now, like I said just now when you answer about the question on the trolley, you are only looking at this part. But for this question, because I'm going to answer about this load part here, so I'm going to only refer to this free body diagram. Okay, I'm going to only refer to this B and T part. So I know that the acceleration of the load is 4 meters per second per second. It is moving down 4 meters per second per second. And then the gravitational acceleration is 9.8 meters per second per second. This is what I know. Okay, now, still, when you answer this kind of question, you have to take into the consideration of the resultant force. So means that to find the resultant force, I need F is equals to MA. But I am asked, this question, I'm asked to find the mass. So what I know here is F is equals to MA. So I'm going to find the value of M. So M multiplied with 4 is 4M. Then my load, the weight of the load, because it is being affected by the gravitational force, so B is equal to mg. Actually, this B refer to berat in BM. So weight and berat are the same. So don't get confused with W and B. B is actually berat. It's the same. B, and then it's go to mg. So my M multiplied with 9.81, I have 9.81 meter. Now, in this situation, you just throw away this part. We just look at this part, T and B. So because the object is moving down, right? So B will always be greater than T. So that's why B is greater than T. So just form the formula F is equals to B minus T. And then I just substitute the value. 4M is equals to 9.81 meter minus 10.8. And then I just rearrange everything. I'll get 9.81 meter. Not meter, this one. 9.81 M minus 4M. And then I get 5.81 M. Then I'll get 10.8 is equal to 5.81. And then M is equals to 10.8 divided by 5.81. And then I get 1.56 kg. So that's how I'm solving it. Okay. Now, if let's say you don't understand, you have to ask tomorrow. Okay. I'm okay if you want to ask. I'm going to explain it again. Let's say you have time, you just rewatch it so that you understand actually what happened. So the pulley part, I have 2 dimensions. Okay. Pulley part, I have 2 dimensions. So that's all from what I want to share in this video. I hope that you watch it and try to understand it. I'll see you in the class tomorrow. Bye.